Today we're going to talk about factoring trinomials of the form x squared plus bx plus c. One key component here is that this coefficient in front of the x squared is 1. So this is technically like ax squared plus bx plus c. And we're just going to be looking at, in this video specifically, when that a value is 1 and how we can factor. When we are factoring in this form of x squared plus bx plus c, what we're looking for is we are looking for two numbers that multiply to c and add up to b. So two numbers that multiply to c and add up to b. And the more you do this, the easier it gets, the better you get at this, the quicker you get at this. So it's starting off, it might be a little bit of a sluggish process, but once you get rolling and you go through and you see a lot of problems, you start to notice patterns and pairings of numbers that like, oh, I see what's happening here. It's going to be this and this. But starting off, it is a little bit of a slow build to get through it. Okay, let's take a look at number 1. So factor x squared plus 5x plus 6. So keep in mind, what we're trying to do is we're trying to factor this to get to a point where it looks like this. It looks like something like x plus 2 times x plus 10, something like that. Where before, when we would multiply, we would do x times x, that's x squared, x times 10 is 10x, 2 times x is 2x, 2 times 10 is 20. So we'd end up with something like this, x squared plus 12x plus 20. We're going backwards now, just like how we were for GCF. We took out a GCF to go backwards from that distributive property. Same exact process, going backwards. So I want two numbers that multiply to 6 and add up to 5. That's specifically what I want. And my answer is going to look like this. When I write my answer, I'm going to write it as two binomials being multiplied together. The first term is x squared, so that's going to be x times x. And then the second term is going to be that multiplication. The two numbers that multiply to 6 add up to 5. So what two numbers multiply to 6 add up to 5? And if you're not sure, you could just go through different factors, like try 6 times 1. 6 times 1 is 6. That's what we want. But look at this. 6 plus 1 is 7. That's not what we want. We want it to add up to 5. So then we got to try another pair. And I know you probably figured it out before I even got there, but I'm just showing you the thought process. 3 times 2 is 6. That's what we want. 3 plus 2 is 5. That's what we want also. We want two numbers that multiply to 6 and also add up to 5. So since we got our pair, and they're both positive, it's going to be x plus 3 and x plus 2. And in the order doesn't matter. You could do x plus 2, x plus 3 in the first parentheses and the second parentheses. It doesn't matter. But we just want x plus 3 times x plus 2 is what we want there. Let's take a look at the next one. Factor x squared plus 2x minus 24. So we want two numbers that multiply to negative 24 and add up to 2. So if we want it to multiply to a negative and we want to add up to a positive, we know one number must be negative, one number must be positive, right? Because we want it to multiply to a negative. If we want to multiply to a negative, you got to have one being negative. So that gets a little difficult. That's when we really have to play around with the pairings of numbers. So first of all, I know it's going to be x and x because this is x squared, so that's x times x. Because when we multiply this back out, remember, x times x is x squared, and then we do the middle terms, 3 and 2, so then we end up with 5x because 3x plus 2x, then 3 times 2 is 6. So we get right back to there. So that's why we have that x times x is x squared, and then those middle terms get those x's, and then the final 3 times 2. So that's what we're doing. So I want two numbers that multiply to negative 24, add up to 2. That's not something, like, don't sit there and just be like, I don't know, like, just go through some numbers. Just start thinking of numbers that multiply to 24. I know 12 multiplies to 12 and 2 multiply to 24. And you need to add up to 2 while one of them is being negative. So if you try negative 12 and 2 and 12 and negative 2, both of those multiply to negative 24. But look at this. Negative 12 plus 2 is negative 10. That's not what we want. 12 plus negative 2 is positive 10. That's not what we want. So 12 and 2 are out. Those do not work. So then try another pair of numbers multiplying to 24. What about 6 and 4? Let's try that. And we want it to multiply to a negative. So we got to do one of them negative, one of them positive. So let's try this out. Negative 6 times 4 is negative 24. Boom. Negative 6 plus 4 is negative 2. That's not good. We want positive 2. 6 times negative 4, check. 6 plus negative 4, positive 2, check. There it is. 6 and negative 4 are my factors. So one is positive 6, so plus 6. The other is negative 4, so minus 4. And you can work this back out and check it, just like how I did over here. You can multiply them back out and see if you get right back to where we started. And you can verify that. But just for the sake of keeping this video in a certain time limit here, not going to expand all those out every single time, but you could if you want. Number 3, that here. Number 3, we want two numbers that multiply to a positive 21 and add up to negative 10. Multiply to a positive 21, add up to negative 10. So if we want two numbers that multiply to a positive and add up to a negative, what do the two numbers have to be? Multiply to a positive, add up to a negative. Both numbers need to be negative, because negative times a negative is a positive, but negative plus a negative is a negative. So we know it needs to be both negatives. So 21, not the most complicated one to figure out numbers that multiply to 21. So that's going to be negative 7 and negative 3. Because negative times a negative is a positive, boom. Negative 7 plus negative 3, negative 10, boom. So that's going to be x minus 7, x minus 3. Number 4, factor x squared minus 3x minus 28. So what we're looking for here is we're looking for two numbers that multiply to a negative 28 while also adding up to a negative 3. 28 isn't the most complicated number to find some factors. We want one of them to be negative and one of them to be positive because we want to multiply to a negative. So one has to be negative, one has to be positive. So let's try 7 and negative 4 and negative 7 and 4. 7 and negative 4 is negative 28, check. But 7 plus negative 4 is positive 3, no good. Negative 7 times 4, negative 28. Negative 7 plus 4 is negative 3, check. And we got them. So x minus 7 and x plus 4. Number 5, two numbers that multiply to 12 and add up to 2. Multiply to 12, add up to 2. We want to multiply to a positive and also add up to a positive, so we know both numbers have to be positives. 12 is 6 times 2. 6 plus 2 is 8. 12 is 4 times 3. 4 plus 3 is 7. 12 is 12 times 1. 12 plus 1 is 13. Can't think of anything else. So it doesn't look like we can do anything that multiplies to a 12 while also adding up to a 2. So therefore, this one is prime. You cannot factor it. There's nothing that works. I just went through them. 6 times 2, 6 plus 2, 8. 4 times 3, 4 plus 3, 7. 12 times 1, 12 plus 1, 13. Nothing works. So that's going to be prime. Then number 6, we have a pretty standard looking trinomial, but this final term has y squared and this middle term has xy. The reason that is because this last term has y squared, so all that we have to do for our answer, the first term has x squared, so that's going to be x and x. But the second term has y squared. The only thing we're going to do is just tack on a y here, because if you think about what's happening, when I multiply y times y, I get y squared. So just that last term needs that y times y, and then we get the middle term is going to work out, whatever these numbers end up being, but the middle term is going to work out because we end up doing like x times y, which is xy, x times y, which is xy. So we're just going to get something xy in the middle once we multiply all that out. So that checks out. So let's go ahead and figure out what our numbers are going to be. So we want two numbers that multiply to 24 while also adding up to 10. So two numbers that multiply to 24 while also adding up to 10. And just to save some time, I'm not going to mess around with all the wrong factors, or I'll go through a couple if it's a tough one. But this one, I'm just going to use 6 and 4. 6 times 4 is 24. 6 plus 4 is 10. They both have to be positive because positive and positive. So that check. So we're just going to write this as x plus 6y and x plus 4y. Made that look kind of bad. X plus 6y and x plus 4y. There it is factored. So don't let that scare you with that y squared. Just the end's going to be y times y. That's all it's going to be. Last couple problems. Factoring x to the fourth minus 3x squared minus 10. So same concept where we just have to find two numbers that multiply to the n and add up to the middle. But what you might notice here is this x to the fourth. And then the middle term is x squared. So think about that. Think about what would we multiply by, the same thing, that would get us to x to the fourth. Well, that would be x squared times x squared, right? Because x squared times x squared is x to the fourth. 2 plus 2 is 4. And then when I multiply my middle terms out, I'm going to be something x squared plus something else x squared. Something plus something x squared is going to be something x squared. So, okay, that's going to check out x to the fourth, x squared, x to the fourth, x squared, and then nothing. So that's all I have to do. I just have to think about, well, what times what is going to be x to the fourth, but it has to be times itself. So x to the second times x to the second, because 2 plus 2. I know I kind of marked this up a lot, so let me erase some of this. Now we need to figure out two numbers that multiply to a negative 10, add up to a negative 3. That's going to be negative 5 and positive 2, because negative 5 times positive 2 is negative 10. Negative 5 plus 2 is negative 3. Check, check, check. So x squared minus 5 and x squared plus 2. One's got to be negative, one's got to be positive, and we figured that 5 is the negative. Very good. Now number 8, weird looking problem. But look, it's a trinomial, 3 terms. We have y to the second, y to the first, no y. So let's just reorganize it. Just move some things around. This is going to be y squared minus 7y minus 60. And then now I could factor, hopefully. At least I can attempt to factor. But now I just have a normal trinomial in that form of ax squared plus bx plus c. I just have the descending order there. So I'm going to have y's in the front because it's y squared. And then I need to figure out this mess. Negative 60 and negative 7. Multiply to negative 60. Add up to negative 7. Off the top of my head, 6 and 10 is 60, but that's not going to be 7 in any way. Let's see, 15 and 4. 15 minus 4 is 11. Not going to work. What about 12? I think 12 actually might work, right? 12 and 5, yeah. 12 is going to work. Okay. So there it is. So I had to do a little bit of some work there. So 12 and 5, now I just need to figure out what the sign is going to be. I need it to multiply to a negative, add to a negative. So I need the bigger number to be negative. So negative 12 times positive 5. Negative 12 times positive 5 is negative 60. Negative 12 plus positive 5 is negative 7. There it is. All right. Wasn't too bad. It looked kind of scary, though. So y minus 12 and y plus 5. I think these are the last two here. So number 9, 3x squared plus 3x minus 1/6/8. So this looks like a trinomial, but not in the form that we've been talking about. Remember what I said at the beginning of this video, ax squared plus bx plus c. And in this video specifically, we are looking at with a is equal to 1. So that leading coefficient is 1. But this isn't 1, this is 3. What we want to hope for is that we could take out the GCF of a 3. We could take out GCF, and then that coefficient, when we divide by 3, is just going to be a 1. So let's see, does 3 factor out? 3 goes into 3, 3 goes into 3, and then 1/6/8, I don't know. So I would do 1/6/8 divided by 3, which is 56. Cool, it does. So since I can factor out a 3, I'm going to take out a 3. So I'm dividing each term by 3. Wouldn't it be the worst idea to just double check, make sure there's nothing that we missed? Like I can't take out an x because this term doesn't have an x. So I can't take out an x. So we're just going to factor out 3. So it leaves me with x squared plus x, and then I just divided 1/6/8 divided by 3 to see if that divides evenly, and it does, and that's 56, so minus 56. Now we need to factor, so don't forget about the 3 though. Just like when we did like factor by grouping, we took out a GCF, you got to make sure that GCF gets tacked on. So whatever that answer comes out to be, we want to make sure that GCF of 3 that we took out comes along for the ride too. So now I'm looking for two numbers that multiply to a negative 56 and add up to 1. 56 looks kind of scary, but since we want it to multiply to, add up to a 1, That's just going to be 7 and 8 because those are a difference of 1. So now we've got to figure out the sign. We want to multiply to a negative, add up to a positive. So that's going to be the bigger number has to be the positive. So 8 times negative 7 is negative 56. 8 plus negative 7 is positive 1. So x plus 8 and x minus 7. And don't forget about that GCF of 3 that we took out. That needs to be part of the answer. Last one. So same exercise as the last one where we have the a term definitely bigger than 1. But 2, 28, and 90 are all even, so I can take out a 2. Also, x to the fourth, I know you might be thinking like, oh, we just do x to the second, just like that other problem that we did. But look at what happens though. This last term is also x to the second. So that doesn't really work. So what we need to do then is factor out a GCF of x to the second because they all have 2 x's. X to the second, x to the third, and x to the fourth all can take out x to the second. So I need to factor out 2x to the second from everything. Two over 2 is 1. X to the fourth over x to the second is x to the second. 28 divided by 2 is 14. And then we have x to the third over x to the second, which is just x. 90 divided by 2 is 45. And then I took out x to the second, so those are gone. So I get 2x to the second. Now we need a factor. Two numbers that multiply to positive 45 and add up to negative 14. Whenever it's multiplying to a positive, adding up to a negative, it almost makes it easier because then you're like, all right, they just have to both be negative, and then they're just going to add together, so that's going to be 9 times 5. So negative 9 times negative 5 is negative 45. Positive 45, excuse me. Negative 9 plus negative 5 is negative 14. So x minus 9, x minus 5. Factored. Don't forget about that GCF. So this video was factoring trinomials in the form of ax squared plus bx plus c, where a is equal to 1.